Exploring Requirement Transiency, Measuring Volatility Through Network Models, an NSF-funded research project conducted by the Systems Research and Intelligent Design and Engineering Lab at Florida Institute of Technology in collaboration with the Clemson Engineering Design Applications and Research Lab. Requirements justify all final design decisions, support conceptual development, and help to allocate resources, so it is important to be mindful of the requirement changes while minimizing propagating effects. When making a design concept, engineers must be wary of requirement changes. This is because of the downstream effects that can come about due to these changes, whether that change was voluntary or unintentional. Therefore, the aim of this research is to propose a new approach for engineers to determine how a change in any one component affects other components in the system that may have otherwise been unpredictable or inconspicuous. Currently, companies with complex engineering projects do not have a way to predict the effect a chosen requirement change may have on other requirements to the nth degree. This project aims to assign volatility measurements to each requirement, thereby allowing engineers and designers extended understanding of the relationship between requirements and their tendency to affect the entire system design. Volatility will be calculated using the four measurements during every instance of change: multiplicity, absorbance, transmittance, and robustness. Requirement changes can be described as follows. A multiplier is a requirement affected by an initial change and thus causes other related requirements to change. An absorber is a requirement affected or changed though does not propagate the immediate change of other requirements. A transmitter is a requirement not affected by an initial change though causes other requirements to change. A robust requirement is not affected by changes in an initial requirement and does not propagate change to other requirements. The results will address the following research questions. Can requirement volatility be measured through multiplicity, absorbance, transmittance, or robustness during every instance of change? Can graph theoretic metrics be utilized to determine the requirement volatility measures? Can the volatility measures be used to determine the impact and propagation that may result due to an initial change? This research will overcome these obstructions in the system design process and allow for better anticipation of requirements, evolution, and potential impacts on the overall design. By enhancing the current RCPPM tool to include quantifiable volatility metrics, the system design process will be less costly, more efficient, and less tedious. This research will introduce a branch of design requirements managed in decision science. This research will also enable the utilization of tools and methods to formalize how we manage requirements evolution. Finally, introducing requirements volatility within the classroom will be a major step toward producing engineers who have the foresight to properly manage design projects before entering industry.